37 orphan sea otter pups were carried into Elkhorn Slough, a shallow, muddy estuary on the central California coast that had been quietly dying for half a century. Between 1956 and 2003, more than half of that estuary simply washed away, banks slumping into the channel, marsh grass sliding under the tide, a landscape eating itself from the edges inward. Nobody released those otters to fix the mud, but within a decade, scientists measuring those creek banks found the erosion had slowed by as much as 90%, and no one could explain how a floating mammal had stopped the ground from disappearing. To understand what happened at Elkhorn Slough, you have to understand what was wrong with it. And the problem did not arrive as a flood or a fire. It seeped in. Beyond the ridge sits the Salinas Valley, some of the most productive farmland on Earth. Beginning in the 1950s, fertilizer-laden runoff from that valley began draining into the estuary. Season after season, decade after decade. Brent Hughes, a coastal ecologist who has spent more than 20 years working in that water, has described the slough as carrying some of the highest nutrient concentrations ever recorded on the planet. Those nutrients fed explosive mats of algae. The algae smothered the eelgrass beds that hold the whole system together. The underwater meadows where juvenile fish shelter and hundreds of bird species come to feed. Then the banks began to go. Burrowing shore crabs, thriving in the altered habitat, chewed through marsh roots and drilled the sediment until it lost its grip on itself. Every tide pulled a little more away. Aerial photographs stretching back to the 1930s record the retreat in slow motion, creek edges peeling backward year after year. Between 1956 and 2003, over half the estuary eroded into open water. Land managers tried everything conventional. Nothing held. What had vanished from that water long before the fertilizer arrived was a predator. Sea otters were gone from the estuary by the early 20th century, stripped out by the fur trade. A raft of about 20 males drifted back into the slough in the 1980s, but they were wanderers, not residents. The females stayed away, and without females there were no pups, and without pups there was no population. 30 kilometers south, inside the Monterey Bay Aquarium, a small team was working on a problem that had nothing to do with erosion. Stranded newborn otter pups wash up along the California coast every year, separated from their mothers, often uninjured but entirely helpless. Raising them by hand produced animals too comfortable around people to survive in the wild. In 2001, a resident female named Tula, unable to be released herself, was given an orphan pup to raise. She accepted it. So did a second female. Those first adoptions became a method. Carl Mayer, the animal care coordinator for the aquarium's sea otter program, and his colleagues built an entire rearing system around it. Human caretakers wear dark cloaks and face shields, so the pups never learn what a person looks like. The surrogate mothers do the rest, teaching the young otters to groom the dense fur that keeps them alive, to dive, to crack open shells and find food on their own. It is the only program of its kind anywhere in the world. And between 2002 and 2016, 37 of those surrogate-raised juveniles were released, not into the open coast where they had stranded, but into the quiet brown channels of Elkhorn Slough. The otters did not need instruction. They needed crabs. An adult sea otter carries no blubber. It burns through roughly 25% of its own body weight in food every single day, just to stay warm in cold water. In the slough, the easiest calories in reach were the burrowing shore crabs, packed into the marsh banks, the same crabs that had been hollowing out the estuary from the inside. Otters dove, surfaced, and ate, then dove again. Sea otters have one unusual quality that makes them extraordinary to study. They bring their prey up to the surface and eat it floating on their backs, in full view. Every meal is a data point, visible through a spotting scope from shore. Hughes was not looking for otters at first. He was counting eelgrass, groping along a silty bottom in water too murky to see through. When he overlaid decades of eelgrass records against decades of otter counts, the two lines moved together. Otters up, seagrass up. Otters down, seagrass down. He has said the two datasets fit like a glove. Published in the Proceedings of the National Academy of Sciences in 2013, that work showed the returning predator was pulling down the crab population, releasing the small grazing invertebrates that scrub algae off the eelgrass blades and letting the meadows breathe. The eelgrass was surviving at nutrient levels roughly 10 times beyond what science said it could tolerate. But eelgrass was only the water column. The banks were still falling in. Then, Hughes and his colleagues noticed something no one had recorded before. The otters had moved out of the open water and into the salt marsh itself, hunting in the narrow tidal creeks that thread through the pickleweed. What followed was one of the most rigorously constructed tests ever run on a recovering predator. The team surveyed 13 tidal creeks across the estuary. They pulled aerial photographs dating back to the 1930s to map erosion across 90 years. They compiled 35,000 direct observations of sea otters feeding in those creeks. And critically, they did not settle for correlation. They built cages, sealing off sections of marsh so otters could not enter, and left them in place for 3 years. Then compared crab numbers, burrow density, and plant matter inside and out. The results were published in Nature on the 31st of January, 2024. In creeks where sea otters were dense, erosion rates were 69% lower than in creeks where they were scarce. In the strongest sections, the marsh edge had stopped retreating by as much as 80 to 90% even as sea levels rose, even as runoff continued, even as every other pressure on the estuary held steady or got worse. Measurements like these take decades to accumulate, and the work at Elkhorn Slough is still running. Subscribing means you will be here when the next set of numbers comes in. Hughes was careful about what the finding did and did not mean. Reintroducing the otters, he noted, did not reverse the losses. It slowed them enough that the system could stabilize. His co-author Brian Silliman of Duke University framed the implication as a question rather than an answer, asking how many other ecosystems worldwide might respond the same way to the return of a former top predator. None of it would have happened at that scale without the pups in the cloaked room. In 2019, the aquarium team published 15 years of tracking data in the journal Oryx. The surrogate-reared otters had not merely survived. They had reproduced at rates comparable to their wild-born kin. 90% of released females and 80% of males stayed in the estuary, rather than striking out for the coast where they had originally stranded, despite having no memory of the slough at all. Together, those 37 animals and their wild-born descendants accounted for more than half of all sea otter population growth in Elkhorn Slough across that period. The resident population climbed steeply from 2002 through 2013 and has since settled at around 110 animals. That is now the densest concentration of sea otters anywhere in California, and roughly 60% of them trace back to a pup that was once raised behind a face shield by a female who could never go home herself. Kyle Van Houten, then the aquarium's chief scientist, put the logic of it plainly. If otters do great things, and there are places missing otters, and there is now a way to change that, then fix it. Elsewhere along the same coast, the law had spent decades trying to do the opposite. In 1986, Congress authorized federal wildlife managers to remove southern sea otters from a management zone stretching from Point Conception all the way south to the Mexican border. The zone was a compromise with shellfish fisheries and offshore oil interests, and its purpose was blunt. Otters eat urchins and abalone. Otters were to be kept out. Beginning in 1987, 140 otters were captured and moved to San Nicolas Island, the most remote of the Channel Islands. It did not work. After 4 years, only about 10% remained. The rest disappeared, died during transport, or drowned trying to swim home, because sea otters possess a homing instinct that no offensive policy could override. Federal managers eventually described their own program as impractical, expensive, harmful to the animals, and futile. The zone was terminated in 2012. Commercial fishing groups sued the following year to force its return. Lower courts upheld the termination. The Ninth Circuit upheld it again. The Supreme Court declined to hear the case. Only then were sea otters legally free to reoccupy the southern half of their own range. Nature does not settle every argument in the recovery's favor. Along the Monterey Peninsula, Joshua Smith logged more than 700 dive trips and roughly 500 hours underwater tracking what otters were doing to the purple urchins that had overrun California's kelp. After the marine heatwave of 2014, the otters there tripled their urchin consumption and the local population swelled from about 270 animals to about 432. And still, the urchin barrens remain. The reason is grim and elegant. Otters were feeding only inside surviving kelp patches, ignoring the barrens entirely, because urchins in a barren have nothing to eat and are essentially hollow inside. Smith calls them zombies. A sea otter will not spend a dive on an empty shell, so the barrens hold, and the kelp survives only where otters were already standing guard. The slough has its limits too. Foraging efficiency there has declined and prey sizes have shrunk, and managers now suspect Elkhorn Slough is approaching capacity. The release program has already turned its attention to other estuaries. Along a coastline that once carried somewhere between 12,000 and 16,000 southern sea otters, roughly 3,000 remain, holding about 13% of their historical range. That gap is not just an animal count. Kelp forests guarded by otters can absorb up to 12 times more carbon dioxide than forests left to the urchins. An Effect 1 analysis valued at between $205 million and $408 million in carbon terms alone. Federal biologists have now formally assessed reintroducing sea otters to Oregon and Northern California and concluded it is feasible biologically, legally, and socioeconomically. Morro Bay is being evaluated as the next place to test the method. On eelgrass beds in the same poor condition Elkhorn Slough was in before the pups arrived. 37 orphans, a cloaked room, and an estuary that stopped dissolving. The mud is still there, the otters are still eating, and the measurements will keep coming in until long after everyone who started this work has retired. But otters are not the only vanished predator being quietly returned to a landscape that forgot them. And in our next video, we follow a species whose reappearance changed the shape of an entire river valley.